Okay, we are on air. Hello, everyone. Welcome to another new session of Tech Athena. For those of you who are new to Tech Athena is a platform where we discuss about new and upcoming technologies. And I also want to apologize to you for because it's been quite a while we held the session. So we are starting a series of sessions which I'm going to share soon. So coming to today's topic, infrastructure for AI. I just want to set a context on what is it we are going to discuss today. So we are going to discuss more from the processing front on the processor and how it has evolved and how the new processors are there in the market which are helping AI go forward. And I have with me today Gerard. He is IBM Technical Sales Executive from Asia Pacific. So that means he oversees implementations across Asia Pacific. So he is going to share his experience with us. And just to give you a brief, little bit more introduction about him, he has 17 plus years of experience, and he has started from the age of automation when people were thinking of automation, and then we moved to analytics, and then we now metamorphed into AI. So he is going to share all his experience today. So with that, I would hand over to Gerard. Welcome, Gerard.
Hi, thank you, Deepthi. Thanks for organizing this session, and I really appreciate your passion in organizing such live sessions. I've learned a lot from you in preparation for this, and I really enjoyed it.
Thank you,
So
Gerard.
I've just started sharing this session, and the PowerPoint is projected. I hope you can see that.
Yes, yes, we can.
Excellent. So we are live, and not only that, I'm very excited because this is the first time I'm live and I'm doing a session on infrastructure for artificial intelligence. At IBM, we call this there should be an IA for AI. What that means is we should have an infrastructure agenda, that is IA, for artificial intelligence. And infrastructure remains at the core of artificial intelligence. That's mainly because customers are at the moment looking at various ways of deploying artificial intelligence, infusing artificial intelligence, and operationalizing it. And therefore, they want to trial and do a lot of trials and development work in their infrastructure. And it also involves understanding the operationalization of these situations, use cases. So infrastructure plays a very key part for our clients. And today I'm going to share that infrastructure agenda. And the session agenda that I have today is I'll make some initial comments and also talk a little bit about the state of AI for 2019, because it has been a few years that we started talking about AI. And then I'll straight away move on to some interesting use cases that we have been part of. Now, these use cases are the latest ones that we have been part of. There are also use cases that we have been trialing with our clients, proof of concepts that we have been doing with our clients over the last 3 to 4 years. I will briefly mention them. Then I'll go into some key value propositions of IBM offerings. And let's also try and answer the question, why IBM? And towards the end, I'll also share some next steps for all of you who are there. Maybe you want to get started with artificial intelligence, some of the use cases, or look at infusing AI to your workplace or wherever you are. So I'll point you to some starters at the end. Let's move on. So one of the things I wanted to cover is what's happening for artificial intelligence in 2019. Now, when we started 2018, the ethics around AI started to kind of take shape. Now, towards the end of last year, that is 2018 December, I saw an article that was titled AI Facial Analysis Demonstrates Both Racial and Gender Bias. And then the author went on to say that this study shows much higher error rates for people who aren't white or male. And that surprised, but not a great deal, because this was kind of taking on in the industry. Then later on, very recently, I think about a week ago, I came across another article that was titled "Artificial Intelligence is on the Brink of a Diversity Disaster." Now, this all points to the fact that ethics in AI is becoming more and more closely watched. It's more and more a concern for some of our clients and enterprises and researchers. And as a result of this, there are few areas that were introduced. First of all, there was a call for more responsibility, more transparency. There was a call for interpretability of the results, and also it all boiled down to the explainability of artificial intelligence and bias mitigation. And at IBM, we didn't stay quiet. We introduced solution called Watson Open Scale, and this was meant to look at measuring and tracking AI outcomes, tune bias for businesses in the area of artificial intelligence. Not only that, we went on to deploy governance and explainability in artificial intelligence. So that's ethics in AI kind of taking front stage. Then we also wanted to look at another trend that is becoming more and more important, that is about reducing training times. Now, over the years, we have seen customers have been trialing and testing more complex use cases, particularly around images, high definition videos, and so on, which essentially meant large amounts of data. Large amounts of data means you had to train for longer times, and multiple iterations were required, which called for reducing the training time, which looks at the technology that is needed for that. So I'll be covering a little bit about how we have deployed some technologies to reduce training times. Thirdly, just something related to the second one I mentioned, computer vision has taken center stage. We all know the saying that a picture is worth 1,000 words. Now, that is for sure applicable in the field of artificial intelligence as well. Essentially because customers are trying to look at a lot of CCTV footage that they have been collecting over the months and years. They are creating drone footages. They are looking at scans, images of health records, and so on and so forth. All this means computer vision, such as images and videos, are becoming more and more becoming part of artificial intelligence journey of our clients. So to pick up these top three sort of trends for 2019, I went through almost about 4 or 5 different articles. Now, on the right-hand side, you can see that I have put them all these articles in Instapaper, and I've kind of highlighted on the right-hand side of this page. You can see 5 artificial intelligence trends, and then another article talks about general trends, and then there are about top 10 trends that another website that was talking about. So from all these different websites, I could kind of pull 3 of them, and I can tell you we are part of each of these top 3 trends. And as we go along in the use cases, I will be explaining to you and talking to you about some of these trends being shown by the proof of concepts and proof of technologies that we are doing for our clients. Moving on, I just thought I'll share with you some of the latest interesting use cases, proof of concepts, proof of technologies that we have been doing with our clients. Now, I have to tell you upfront that most of our clients whom we work with, prospects we work with, they do not want to be sharing all the details about what they're doing. In some cases, we do take permission from our clients. In some cases, we kind of bring up some use cases that we thought that would be interesting for our clients. And here, we have been trialing some use cases around retail industry. Now, as we all know, retail industry is very, very competitive, and customers want to do something new. Customers want to do something more innovative for their own clients so that customers are taken care of. Now, right here on the left hand side top corner, it's a simple use case of counting the number of clients walking into a supermarket in this case. Now, what has counting got to do with clients walking into the supermarket? It's about providing personalized service. It's about understanding where we have the most number of crowds. Now, you might have noticed already on the left-hand side top corner that we are also detecting the possible age of that person. We are also getting details, if that customer is an important customer or a loyal customer. We are also, showing the picture of that customer. And it's all about optimizing the sales. It's all about the trolleys the customers are using, and they are placed in the right entrance, especially for a supermarket that's of large size. Let's say it's got 30 different doors and customers walking via these 30 different doors, and we want to make sure that they have a pleasant experience as they walk in. Then on the right hand side, again, it's about customer satisfaction, keeping customers happy during their shopping experience. Now, what you're seeing is measuring the queue length, and based on that, an alert is placed to the store manager. And you would have already noticed when the line length was long, the manager who was doing something else in this small little supermarket immediately walked in. So he got an alert, he started to walk in. And that is important in a retail store of this size, which is very small. And we want to serve, maybe open up more counters when the queue is longer, and we want to ask more of the retail store executives to be part of the experience for the clients and help the clients to finish their shopping much faster. Then we also did another proof of concept in a large supermarket. Here it's about identifying the personality of the client, what items they are shopping, and what is the time period they are in the supermarket. And based on that, we are also looking at patterns around which gender, what is the possible age group, and what are the items they are shopping for during the various periods of their shopping experience. Now, all this points to customer satisfaction, being able to be more competitive in the fiercely competitive retail market space, uh, and to serve the clients in best possible ways. And these are innovative solutions that our clients and prospects are looking at, are interested in. Now, on the left-hand side bottom corner is a trend that has taken place more recently, where customers have started looking at self-service shopping experience. Now, self-service shopping experience is good because you get the shopping done faster, but there are also millions of dollars being lost because of clients trying to avoid scanning some of the items. Now, you want to be notified as a retail store owner if somebody is trying to avoid scanning items that are of higher value, because retailers are losing millions of dollars across the globe due to this situation. Um, in one hand, customers have the convenience of doing self-service shopping, but on the other hand, retailers are losing also because of certain situations like scan avoidance. Now, you would have already noticed in this trial video, it's a complex move that is identified by looking at the movement of the customer and then detecting that he has avoided scanning one particular item or a few particular items. Now, in a operationalized scenario, the store manager or someone in the store would be notified immediately, and he would come and do a check or provide assistance to client in doing the right thing. So these are some of the interesting situations, use cases that we have looked at in the retail industry, which has infused AI to retailers. Let's move on to the next one, which is around sports. Now, sports is something that IBM has been part of for many long years. We have been part of the Wimbledon, and the most familiar scene that you would have seen if you were watching Wimbledon competition is that the speed of the ball is detected during the time of serve, and then it is displayed in a board along with the IBM logo. Now that was quite common and has been there for many number of years. Now at IBM we have been doing this in multiple fronts, actually, in contributing to sports. Last year, 2018, in US Open, we started to train um, players based on the past video footage and the games they had played, and we provided assistance. And more recently, we have been actively involved in NBA. So that's what you see on uh, the top two videos up the top there. Now, this is about understanding very complex moves, and we call it action detection, and providing input to the NBA best player scoring for that game. Now, if you have familiarity with one of the most popular games on earth, basketball, you might know that basketball has got very complex moves. The moves I just recently learned are in 8 different major categories, and there are about 50 or different types of moves. Now, just to give you a little bit of an example, there is a particular category called dribbling, and there is things like Euro step, pro hop, Euro step, power up, over the head, and so on. These are the different types of moves. And then there is also passes. There are different types of passes: bounce pass, chest pass, over the head pass, touch pass, lance pass, jump pass, blind pass, behind the back pass, and so on and so forth. So as you can see, it's got very complex moves, and it all goes towards scoring and identifying the profile of that player and contributing to points to that player, so that the best player is not just about who scores the highest number of baskets, but it's more than that. So we and our research team collaborated with NBA, and we identified some use cases in order to um, contribute towards the best player of that particular game. And we did some trials, and what you see is some trial videos where we identified these complex move for different players. We not only detect who the player is by looking at the face profile of that player, and not only that, we started giving him points and scorings based on every move of that player. Now, this is a very complex involvement to infuse artificial intelligence into the world of basketball. Then on the right hand side bottom corner, what you see is a car race competition. Now, typically what you see on the screen is the elapsed time, the teams, But with artificial intelligence infused, what we have started to look at is the advertiser's screen time. So whenever the video footage points to an advertisement, we started calculating the time the particular advertisement is on screen, and that contributed towards understanding if the vendor is given sufficient screen time or the advertiser is sufficient screen time. And not only that, we also started to track team screen times. So this will all go into contributing towards best customer experience, looking at some of these Formula One races more intuitively, and based on that, rewarding the teams and ensuring that there is equality maintained throughout the competition. So these are in analysis stage, but you can see the way artificial intelligence has penetrated into the world of sports. Let's move on. Let me take you to another industry segment. This is about smarter cities. Governments are looking at cities overcrowded. Countries are struggling with safety mechanisms deployed in the cities. Not only that, there are improvements required in some of the cities in order to have a more pleasant experience. This use case is around safer city initiatives where traffic intersections are being monitored to detect actions like near misses, accidents, threats that demand immediate attention for help. Now, what you see on the left-hand corner is a small little proof of concept which indicates a near miss. In this case, the vehicle should have waited for a little longer, or maybe the traffic lights need some tweaking. This calls for further analysis and further understanding without disrupting the traffic conditions and giving a more safer and at the same time comfortable experience for both motorists and pedestrians. So such cases are important for us to further optimize and provide a safer and comfortable experience for all those who are using the roads. So that's about smarter cities and infusing intelligence into the way the roads are monitored and managed. On the right-hand side corner, top, what you see is drone footage. It's all about detecting various objects, people that you see and their movements, the types of movements. Are they loitering around? Is the person there in that particular area for a longer time? What is the action that he's doing? Is that action a suspicious activity? And so on and so forth. Now, this can also be used for safety of the environment. I know in a particular country, they are trialing by sending drones to construction sites to look at if there are water puddles in the construction site. And if there are water puddles, that could be cause for mosquito breeding. It could also be causing inconvenience to the construction workers, depending on what type of water puddle. It could be oil spill and various sort of unauthorized activities that may be happening in that construction site. So that again is another interesting use case that is used in context with smarter cities in construction sites, which is again deploying drones. Then looking at the right-hand side bottom corner, what you see there is another smarter city initiative by which cameras are deployed not only for monitoring traffic, but also for the parking of the vehicles along the streets. So you might have already noticed a vehicle coming in and waiting to be parked, and then another vehicle taking off, and the second vehicle coming in and parking. And then on the right hand side there is an indicator that will say, you know, which of the parking lots are occupied, and you can go and click and find out the history and how long the user has parked there. And when the user moves out of that parking lot, the parking fee is automatically calculated based on the time out of the day, and then his credit card is charged for the number of hours he has parked. Now, looking at this use case itself, you can see that, or you may be even wondering, why should we use this type of complex AI-based parking for street side parking? Now, the idea behind this is, in this city, they had already deployed multiple number of cameras, and this being a modern city, they thought they could make use of the existing cameras in order to also provide services towards finding out the parking tickets. And not only that, this particular city has future plans to use the same model to be able to detect maybe unauthorized activities, people loitering in that area, illegal moves of the vehicles, and so on and so forth. Now, this would all contribute towards smarter, safer, more secure streets in the cities that are becoming more and more overcrowded. Sorry, I have to go back to the previous page. So the last use case that you see on the left-hand side bottom corner is a simple case of counting the types of vehicles that are crossing a particular point. Now, this is a very simple use case. Now, what you're seeing is the different categories defined: a green taxi, red taxi, van, bus, truck, blue taxi, private car, motorcycle, minibus, flatbed truck, and concrete mixer, and so on and so forth. Now, by looking at this, the different categories of vehicles over a period of time during the day, night, seasonal, and so on and so forth, the authorities are able to find out traffic patterns, different vehicle movements, and in areas where there are toll charged, you can also find out, you know, which vehicle needs to be charged for the movements, and you know, kind of optimizing the way in which that particular street is maintained and managed and looked at. So this use case can be expanded for multiple different purposes in making the city smarter and more secure. Now, one thing I actually forgot to mention is that some of these use cases are being looked at for multiple industries. Now, in the previous page, you might already recall that I was looking at counting the number of people and defining whether the queue is long or medium or short. Now, this was a case that we trialed in a retail store, but in another country, we looked at the banking industry, and they were telling that most of the senior citizens are still using the traditional ways of banking, and they go and stand in the queues, and they needed a better service. So you can see this same concept and same idea and innovation can be also deployed in banks. Looking at monitoring the queues, looking at optimizing the queues, looking at, you know, which time period the queues become longer, and based on that, opening up more counters in the bank, and what type of services are used the most, and based on that, optimizing those services. These are all interesting use cases that can be also cross-pollinated and looked at for other industries. Let me move on to the next page. Here we are looking at the various industries, and I've just taken a couple of samples from two other industries. The first one is, of course, on the right hand side. I wanted to just bring up um, a use case of a drone flying over the field of solar panels to notify maintenance required for a damaged cell. Now, this is a small little solar farm that we did a trial on, but across the globe, more and more solar cells, solar farms are deployed, and thousands of solar cells and solar panels are put in place for getting energy through solar power. And that also means these solar panels require maintenance, and if there is damaged cells that require quicker maintenance in order to optimize and provide the greatest possible efficiency for the solar farm. Now, we trial this to detect damaged cells and then to be able to quickly replace them so that the efficiency of the solar farm is maintained at its peak all the time. Now, the one on the left-hand side that you see is a safety use case for industry, maybe chemical industry or oil industry, where users or workers, professionals are required to wear certain types of safety equipment. And if they are not wearing those equipment and gadgets, that means their safety is compromised. Not only that, this particular video can zoom in and look at any anomalies. Is the worker repairing the area, or maintaining the area that he's supposed to look at? Are there any other safety threats in that area? Based on that, each one of these scenarios can be monitored and maintained. Now, in this case, you might have noticed the video is tracking the person's movement. It's tracking towards the person wearing the helmet and goggles, and looking at his hand gloves. And not only that, it's pointing to an area that the worker is supposed to be working in. And when the worker comes into that focus, the area turns red and ensures that the worker is performing the task that is required to. Let's move on to the next page. Here is a few use cases around safety and security. The first one that you see on the left-hand side is about object detection, suspicious activity, and alerting the security when a person walks in with the suspicious object. And that was a use case that we trialed in a workplace. Then what you see on the right hand side, both use cases are around airport maintenance and activities in the airport. Travel, particularly air travel, has been on the increase. And airports are vying to take the top spot in the regions. So very recently, we worked with an airport in the region, and we wanted to provide the best service experience by looking at their interested areas that they want to focus on. So we actually worked with the authorities and looked at multiple different use cases for a better experience and providing better services for in the airport industry for that particular airport to become more competitive. It's about monitoring the luggage on the belt. It's about ensuring that the plane can come to its parking bay without any disruptions. It's also about the shops
in the airport, where the retailers can look at a more um, intelligent shopping experience um, for their customers, which is not shown here in this example. But we looked at all these interesting use cases. It is also about providing intelligent recommendation to retailers based on what the shoppers are browsing in the airports, and during what times the stores are crowded, and during what time they are quiet. um, and then also about monitoring the number of trolleys in the different parking areas, near the different belts in the airport, and all this. Now, I just wanted to mention also, when we worked with this particular airport authority, we were the only vendor who were able to satisfy all their um, use cases and provide them a very good experience. And as a result of that, we have just won a project. Moving on, this is another interesting example of a client in the insurance industry, where they were looking at providing a much faster experience to their clients in terms of insurance claims. Now, I've given a little chart at the bottom, which looks at the conventional way, um, a typical mobile experience, and on top of that, infusing AI for the clients. Now, this particular client looked at their insurance claim patterns, and they figured out there are about 35 different brands or models of cars that make the most frequent claims on insurances for small damages. Now, in the traditional way, this experience took them the process of physical inspection of the damaged car, and engaging the surveyors, and it on average took about 6 days to perform the task. And that was okay, but there were some clients who needed a better service. And as a result of that, I think it was a couple of years ago, or about a year ago, this particular organization started using mobile apps to provide a more um, uh, smoother experience, much faster experience for their clients. And they called it the paperless claim settlement. And it involved leveraging the smartphone capabilities. The customer had to download the app if he had not, and then taking a picture and sending. And all in all, the entire process on average took about 5 hours to settle the insurance claims. Now, more recently, they looked at infusing artificial intelligence into this entire process. It was about automatic damage assessment by looking at the images that are captured by the client, and this didn't require a surveyor. But currently, this particular client is running as a monitored process, and looking at optimizing it. And on average, what they found out is the claims could be settled in about 10 minutes for the particular models of car. They have not rolled it out to all the models of cars and all the scenarios, but they are seeing some really good early success. Now, why I'm telling about all these use cases is that there is an infrastructure that needed for these clients and for these use cases to be trialed and tested, and ensured that they had the greatest accuracy, and they could trial the best possible scenarios. And customers looked into the right infrastructure. They were looking at things like reducing their training time, optimizing the neural networks for some of the use cases, and submitting multiple jobs to perform multiple use cases and trainings, and this all needed the right infrastructure agenda for their clients. They wanted to ensure that they gain competitive advantage in the fastest possible times. They also needed to gain this competitive advantage in the fastest possible times because of the simple reason things go out of date so quickly. Now, I'll give you a very simple example of a client trying to look at fraud patterns in credit cards. Now, they had huge amounts of data, and not only that, they also needed to um, get with the greatest possible accuracy. Now, one particular use case that they wanted to train um, took about 16 days with the type of setup that they had. Now, they definitely needed something much faster. Now, as you know, fraud pattern changes and they keep changing all the time. Now, if the client took, let's say, for example, 6 months to 8 months to deploy this particular use case, now 6 months is a very long time. And within that period, the fraud patterns would have completely changed. Now, what good is it if the model that is launched to detect fraud does not look at the latest fraud patterns? So it's not useful at all. So customers in certain industry require the right infrastructure setup, the right speed at which they will have to go to solve the complex scenarios and infuse artificial intelligence. And that's what we have been looking at IBM, and we have been looking at together with the multiple partnerships with our vendors. So in the next few slides, I will kind of walk you through some of the interesting discoveries and inventions and innovations that we have put into infrastructure in our organization. Now, the first one we came out with um, is the power system that is codenamed AC922, which is meant for um, the artificial intelligence type of workloads. It is the best infrastructure for AI and high performance computing. It is the it we call this the cognitive server, and we fondly call this the Newell. Newell actually is an English word that essentially taken out of the dictionary, which stands for the center pillar of a winding staircase. Now, customers are climbing their AI ladder, and as they climb the AI ladder, we want our customers to take up this Power 9 AC922 server, which is designed. It is, in fact, not just by IBM, it is a co-designed server together with some of the top vendors in the industry to take care of multiple um, different acceleration points for our clients. So AC itself stands for accelerated computing, and the 9 here stands for Power 9, and it's a 2U server with 2 sockets. Now, what are some of the interesting design points that we have here? And the first point that I would like to highlight here is that this server has got 6 ways of accelerating. Out of which some of the items that I want to highlight here is that we've got industry's first PCIe Gen 4. We've got on-chip acceleration, we've got on-chip encryption capabilities, and also we've got something called NVLink, which I will talk in more detail about, which is a link between the CPUs and the GPUs in the multiple different configurations. Then we've got the Power 9 chips, which in this case has got, there are 2 sockets in this server, and we've got 32 or 40 fully activated cores for our clients. What is also important is that each one of these cores have got up to 8 threads. And not only that, depending on the type of workloads that the clients have, these number of threads can be dynamically adjusted and changed from a single thread to 2 threads, 4 threads, or 8 threads. And this can all be done on the fly depending on the workload that the client is running. If there are workloads that require multiple threads, then they can quickly look at the option of 8 threads per core and activate multiple threads on the fly without having to reboot the server or without having to restart the application or the VM. Then, of course, we've got up to 8 terabytes of local storage in the server. Then, of course, if you require additional storage, you can expand your storage to through an external storage option which IBM has, and up to 1 terabytes of memory. Um, so the important point is to remember that this is a fat system. What I mean by that is it is well designed and optimized to take care of the type of workloads that you may be running and the dynamic real-time capabilities that you have built into this server. Now, um, one thing that I have not mentioned here is the number of GPUs that you can have in this server. You can have up to 6 GPUs in this server, and the most popular one being the 4 GPU configuration, or even in some cases, customers want to started small, and they start with 2 GPUs. Now, these GPUs are NVIDIA GPUs, and they are the V100 types, the Volta 100 GPUs, which can have up to 32 gigabytes of local memory. So it's a well balanced, fat system that is able to take care of your AI workloads and provide the best optimized experience and do the training in the fastest possible times. Now, from here onwards, I will also talk about some of the technology innovations that we have built in, both at the level of hardware as well as some of the software tools that we have packaged in together with this server. And in that lineup, the first one I would like to mention is the Power 9 server, the AC922 server with NVLink capability. Now, if you look into the server design point here, you can see that the V100 GPUs that I mentioned have got this NVLink, which we co-designed with NVIDIA. It has a speed of 150 gigabytes per second. So in in areas where we look at complex workloads, these link comes very handy. Not only the link between the GPUs, but also the link between the GPU and the CPU, which functions at almost the same speed, which is again 150 gigabytes per second. So you can see the link is all across between GPUs or between the GPUs and the CPU. Is 150 gigabytes per second. Now, one more point to take note here is that the memory, the main memory of the computer, and the interaction with the CPU is at the speed of 170 gigabytes, which is almost as close as the speeds that we have between the GPUs and the GPU and the CPU. Now, this is what I meant by fat system, which has got the bandwidth, which is almost the same speeds as that of the link between the GPUs and the GPU and CPU. Now, this provides a well balanced design for our system. Now, there are other vendors who look at much more number of GPUs, and where they fail is to look at the the well balanced capability of the system. Whereas we have taken a closer look at that, and this provides up to 5 times faster data transfer with the unique CPU to GPU NVLink connection to our clients. And the key point to note is there is no bottlenecks because the speeds are almost same. There's no bottleneck. Let me move on to the second differentiator. Now, this differentiator is called large model support. Now, here there are 4 different scenarios that I have painted. These are all relating to use cases that require very large amounts of memories to complete the training task. Now, what you see on the left hand side is around um, uh, scans for various illnesses, and these scans are very high resolution, and they require um, to be looked at. When multiple images are used, you need large amounts of memory. Then in the area of security, when you when the surveillance systems are deployed in multiple rooms in an organization, then you require large amounts of data to be looked at for training purposes for that use case to take shape. Then when you look at drone footage, or when you look at the area of defect detection, you require very large amounts of data in order to look at training. Now, as I mentioned earlier, the GPUs have got memory, and these memory can go up to about 32 gigabytes per GPU. Now, when we train large number of data sets, maybe thousands of um, images for medical scan, and when we look at that and perform the training, we run into situations like out of memory. Now, that is where large model support, which we have as part of our software package, which is called Power AI, provides the capability for customers to look at large data sets. Now, these large images are also very high resolutions. Now, the higher the resolution is, the more details that you can unearth. Now, you can see on these pictures of Mona Lisa, you can see if the picture is low resolution, you can hardly get any details. Whereas if it's of high resolution, you can grab as many details as possible in order to get more informed decisions, or in order to understand more about the particular image or pattern. So what we actually did was we used some high resolution images, and we did a test using our system versus the competitive system, and we could achieve up to 4 times faster training times using our AC922s with NVIDIA V100 GPUs. Now, this really matters because customers are looking at ways of training quicker and providing insights to be able to be competitive. Now, the faster you can train, the quicker you can get the accuracy, and then the faster you can get back to deploying these models, and that really matters. So, large model support is a very important technology differentiator that we have in our service. Then let's move on to the next differentiator, which I call distributed deep learning. Now, deep learning has been gaining popularity mainly because it provides greater accuracy, and it looks at much deeper and complex use cases. Now, typically, when the customers get started, they get started with a single node because the workloads are not that much. But as they expand, as they look at multiple use cases, and as they look at complex scenarios, they require multiple computer nodes. Now, the challenge of performing deep learning training using multiple nodes, is that the efficiency can be lost, and as a result of that, it may take longer training times to perform complex use cases. So what we have come out with this is a distributed deep learning capability, which is kind of an industry standard. But what we have done is we have implemented it in such a way that it provides the greatest efficiency, and we have the record for providing the best efficiency in the industry. To give you one quick example, when a training job was done with one system, one of the nodes, it took about 16 days to perform that particular training iteration. When 64 systems were connected together, so obviously we are looking at each system with 4 GPUs and about 256 GPUs performing the task, could be done within 7 hours. Now, you may be questioning what's a big deal, because they have used 64 systems and they were connected. The big deal is about the efficiency. Now, here you can see when a system with the 4 GPUs becomes with 16 GPUs, the speed up that we are getting and the scaling we are achieving is near ideal scaling. And as a result of that, resources are not wasted, and we are able to provide the best possible efficiency for connecting up 256 GPUs in the marketplace. Now, this, of course, when clients grow their workloads, when they look at much more complex scenarios, we this technology becomes definitely handy for customers to look at. Moving on to the next differentiator, we have the recently renamed IBM Watson Machine Learning Accelerator, which used to be called IBM Power AI Enterprise. Now, one thing I forgot to mention is that when I talked about IBM Power AI, it is a collection of open source packages and the various utilities and packages that are required for customers to get started with their deep learning projects. Now, there are, of course, so many different open source deep learning frameworks that are available in the marketplace. What we did was we picked up the most popular deep learning frameworks and the required drivers and necessary interfaces and utilities, and put them all together and packaged them, and called it IBM Power AI. Now, this, of course, is optimized, and it is in line with the open source package releases, and we got our clients started. It is free of charge, and customers can download and use on our server. If they require maintenance, we provide that also for our clients. Now, customers who were getting into more complex tasks, they needed a much more robust software framework environment. So we created this IBM Power AI Enterprise, which is now renamed IBM Watson Machine Learning Accelerator. It is an enterprise ready software distribution based again on open source, and it provides faster training time for data scientists. So we have, of course, optimized and compiled the various deep learning frameworks to match some of our technology innovations that we have put in place, such as large model support and distributed deep learning, and so on and so forth. And not only that, customers needed tools for ease of developments of their workloads. Customers needed to look at real-time monitoring of hyperparameters for deep learning frameworks. So we created a dashboard that allows the customer to investigate these parameters and monitor them while the training is progressing. Now, if the training need to be aborted well in advance, we would notify them that no, this training is not going anywhere. You need to further tweak the hyperparameters, and the training could be aborted with, of course, user intervention. Now, all that means is that customers can, who are looking at training their deep neural networks, can monitor the hyperparameters and abort training in advance and resubmit their jobs in order to optimize and do the tasks more efficiently. Let's move on to the next differentiator. Um, the next differentiator is around um, another tool that we designed, which we call IBM Power AI Vision. Now, as the name suggests, it's all about computer vision, and we had a lot of demand from our clients to look at their image data and their video data. And customers also had challenge around finding the right skills to get started with their AI journey. Not every client had data scientists. They needed an easy to use point and click tool for computer vision. That is exactly what we delivered to our clients. Now, this is a very easy to get start tool for computer vision related applications and use cases. It is so easy that we even invited some of the secondary school students to use the tool and develop their deep neural network and a computer vision model for simple use cases. It is a point and click tool. There's very less coding involved. It's about clicking and creating your computer vision models. So it's got some really neat capabilities that I want to just mention. First one is semi-auto labeling capabilities for images. What that means is, let's say you got about 10,000 images, and before you can train on those images, you need to label. Let's say, for example, for the case of object detection, you need to draw bounding boxes around the objects that are of interest. Let's say in this case, you want to draw bounding boxes for cars. So in one computer frame, in this case, you're seeing how many cars? About 7 cars. So you needed to draw bounding boxes around each one of these images. And if you got 10,000 images, then you of course need to do this multiple number of times. And what we provide through the semi-automated labeling capabilities is that sort of using AI for AI. So you take a subset of the images and you draw bounding box, and then you use that as a base, and then you train the rest of the images and validate that the bounding boxes have been done correctly. And in that way, you perform your task of placing bounding boxes around much faster, up to 10 to 20 times faster than how a traditional system or a traditional software tool would do. So this provided much ease and greater productivity. Now, the next challenge that most of our users, clients had is that dealing with so many complex parameters and tuning that is required at the time of training the the deep learning model. Now, we gave customers two different options. One is you perform auto training of the AI model, which of course did not require clients to mess around, the users to mess around with the parameters and their values. Based on the image type that is chosen, the type of use case, we went ahead and defined the optimized model that is required to perform the training task and to build the model. And for advanced users, like customers who got their data scientists, we also provided them the option of being able to um, tinker around with these parameters and provide greater accuracy and greater details around it. Then we also provided them multiple packaging options at edge. If clients needed to use their mobile phones, or if they wanted to use their web interface or drones or even cloud, we provided them multiple packaging and deploying options. So that's all in all the different capabilities of IBM Power AI Vision. It's a point and click tool for computer vision for users to get started much easier. And I have also provided a link for you if you are interested in going and learning more about it, and also if you want to do a trial of this particular tool for 30 days, and you can look at the tool and its capabilities. Moving on, the last one I have as a differentiator is a tool that we have collaborated with one of our partners, H2O.ai. They have got multiple offerings, but we have partnered with them to run and deploy H2O driverless AI software package, which is an expert data scientist in a box. It provides multiple capabilities for users to get started with text data or numbers um, in such a way. It's almost like the Power AI Vision tool. It provides multiple ways of automations, looking at the various visualizations of the data, looking at feature engineering, which has never been done before at this level, and looking at model tunings and various ways of automating time series data. And also we created multiple ways of deployment using low latency inferencing capability. Now, the biggest challenge that our clients had, especially when it came to financial industry data, is about trust. How would you explain a decision that the AI has taken with proper logic and pathway? So we create, of course, together with the H2O, the tool creators, they provided this option for clear-cut explainability of the model that has come out with, and automatic documentation of the decision. So once you develop a model using the tool, at the end, this tool would provide automatic documentation to explain the logic behind coming out with decisions. I thought I'll suggest some possible next steps. I'm sure as you listen to this presentation, you may be wondering, well, I'm interested in a deep dive of the large model support. I'm interested in learning more about Power AI Vision. Now, if you are interested, maybe you can mention in the chat about your interest, and we could do a session subsequently after this and look at some of your interest. And I can walk you through a demonstration or a deep dive session, or I can get my colleagues involved to help you in understanding more about the technology. We also do cognitive discovery workshops for our clients. If you are interested in any one of them, do let us know. They are customized discovery workshops depending on what stage of the journey our clients are in. Some clients I've seen, they've got their data scientists and they've got a fairly large AI deep learning practice within the organization. The largest one that I have come across is about 40 different data scientists working together to solve problems and to infuse innovation and AI into the work streams. But there are also clients that I've come across who don't know anything in the sense of getting started with AI, and they are interested. They do not have data scientists. They just have the data. They need help. So we customize our cognitive discovery workshops and provide assistance to clients. Then for customers who are interested in, we also provide an MVP development, a minimum viable product development. So in this case, we work with the client, we define a success criteria, we define a viable product development that they want to look at, and then we deliver that to our clients, and we also provide the necessary training and documentation so that they can continue developing and looking at the various use cases for the success of their business.
Thanks, Gerard. It's
Uh,
very
then I have also provided Deepti, did you?
yeah. Uh, Thanks, Gerard. Actually, it's quite interesting. There are a lot of things which amazed me, especially the throughput between the CPU and GPU, 150 Gbps. Just a question:
Sure.
what is the protocol which is used there?
So that is a proprietary link that we co-developed with NVIDIA, and we call it NVLink. So it uses a proprietary protocol within those links, and they are infused between the CPUs and GPUs and in the motherboard to provide that level of speeds.
Okay. And yeah, and the Power AI Vision and H2O tools which you told, I think they will decrease the work of the data scientist, right? Will actually make
Absolutely.
it easier for them.
It does not take away the data scientist
Yeah.
involvement, but it definitely decreases the time to value for the data scientists, and it provides them a lot of capabilities where they did not have to code. They can just go through the predefined templates. They can just go through the various visualization capabilities that are already defined in the tool.
Okay. So yeah, a few from our audience were asking, where do I start? I haven't got onto AI till now. I only have been learning. How do I start getting into AI?
Right. I think that is a typical question that I've been getting in the various conferences that I've been speaking, as well as when I interact with customers. So the answer is actually in the slide that I'm just projecting, Deepti. Um, uh, th- Customers are in different stages of their AI journey. Some are just starting from zero, some are in step one, step two, and so on and so forth. So depending on their interest, we can converse with them, communicate with them, and try to understand where they are at in their journey. Or we can kind of encourage them to look at some of the tools by looking at a trial download. Or the third link that I provided in item number 4 is actually a cloud-based AI vision deployment that the customer can get started with, and try it on their own. But I would strongly encourage whoever it is. It could be a customer, it could be an AI enthusiast who is from the academia. If they are interested, they connect with me or with you or by yourself,
Yeah.
and we talk to them, and we walk them through, maybe through another short session of what is the interest in, for example, Power AI Vision. Then I've also provided some IBM Red books. Now, the new generation of professionals who are coming out may not know about our red books. If you go to redbooks.ibm.com, you will see a lot of publications which are designed for customers and enthusiasts to get started with. So I've just outlined 3
Yeah.
of those red books
Just
which
to
could be
add
of great
what
value.
Gerard told, they are free and they are publicly available. They're not,
Exactly. You're
yeah,
absolutely right. They are free, they are publicly available. You can download the PDFs and keep it for yourself, and you can learn. And the latest one we have is the number A, which is AI and Big Data on IBM Power System Service. It was just released a couple of weeks ago. And then we have the technical overview and a deep dive of the system. Then we have also provided a red book about our Power AI software package. So these are all very interesting reading for customers to get started, AI enthusiasts to get started.
so there
So
is
these are good points for starting.
one question which we got. It would someone by name Anonymous 15. He says, it would be really great if you can have a workshop to help use a framework for MI or AI, ML or AI. For example, for some example project, if you have some already ready documentation for such a project, then we can do it ourselves.
Okay. So that is perfectly fine. So what they can do is, maybe I'll just move to the next page. They can send me an email, and I have my contact number here. They can connect with me, and we can maybe discuss further and try to understand what the use case is. If we have the skills, we can probably even provide some guidance for them to get started, and we can provide them access to a cloud-based deployment for them to get started. That is perfectly possible. So if you could just let the person know they can connect with me, that'll be
And
great.
you can also reach out to us, Tekatina. We can also connect you with Gerard or
Exactly.
any of
Yes.
the engineers.
Perfectly fine.
Yeah. So yeah, Gerard, can you come back to the normal person? Can you remove the presentation?
Sure.
Yeah.
No problem. So let me stop sharing. That's what I'm supposed to do. And let me get back to
Yeah. And
the.
first of all, I want to thank you very much for taking your time. Just to tell everyone, Gerard has joined us from Singapore. He's a very, very busy person, and he has taken time out to share his knowledge with us. Thank you very much, Gerard.
No problem at all, Deepthi. It was a great learning experience about live webcasting for me. So you got great skills there, and hopefully we can do something more for our clients and AI enthusiasts out there.
Yes, and everyone, please do join or please do subscribe to our channel. And you can always follow us on Meetup and even on YouTube. So whenever we go live, you will get a notification. Hence, I would request you to please subscribe. And thank you for your time today. And
Thank you. Thank you, Deepthi.
yeah, thanks.
Bye.